So moving on then in the series, we're going to be talking about RCDs. Now they're a hot topic at the moment. People are sort of not really getting confused, Tim, but they're not sure where to turn to.
Yeah, perhaps not sure which one to pick under different circumstances and recognising which is relevant. I mean, generally they're going to look at the price. And the problem with selecting by price is you're always going to go for a Type AC and think that you've picked something appropriate, when in reality the connected load may require an F or a B and something to take account of the DC current that exists or the increasing frequency that exists.
Okay.
And particularly, again, we touched on the merging technologies.
Yeah. So we're concerning ourselves here with 531.3.3 types of RCDs, and that's going to give us a little bit of a background as to what each individual RCD does. We've probably done a video before. I'm sure we've done a video before around RCDs and the different types. And if you've seen any of our technical content via CPDs, we do some RCD content around that as well. But really focusing on the range here with the Elucian three-phase setup. So as you can see, we've got some devices on the end here. We've got RCBOs and RCDs as well. 4 different types then, Tim. We've got an AC, we've got an A, we've got an F, and we've got a B. I know there is a B plus kicking about as well, but we're not going to touch on that one today. So the 4 main ones that are in the regulations as it stands. And the reasons we're talking to you about it is because we have included the Type B into the range. Now, that's very important when it comes to the type of installations you're going to be doing when it comes to three-phase and some of the emerging technologies that we've already spoken about. So, subtle differences between the 4 different types, isn't there?
Yeah, I mean, the fundamental principle of operation of all of them is the same. Mm-hmm. It looks for an imbalance between what is the line and neutral current in a single-phase device or between the line conductors and neutral in a three-phase device. And so the fundamentals haven't changed. Mm-hmm. What changes with each of them is their ability to manage levels of DC current that naturally exist because of the electronics that's connected, and the levels of frequency that perhaps might exist, particularly when you're dealing with frequency motors and the things like that, such that the frequency is different to the 50 hertz that we normally have.
You've mentioned DC there, though. We generally deal with AC.
We do, but the things we connect up create a DC connection onto our system, and so it sticks a certain level of DC current onto the protective conductor. It might be via a functional earth, it might be for all sorts of other reasons, but we do create that. And we also connect up to DC components. Battery is a DC component, whether it be in a car or whether it be from a solar PV system, there is DC.
Okay. So how do we know which one we need to select then?
We need to know the nature of the load.
Okay.
The minute we know the nature of the load, and perhaps that might be a manufacturer saying, by the way, please put in a Type B device, at which point you follow manufacturer's instructions, you select a Type B device, you install a Type B device. You don't just go, well, I've considered the manufacturer's instructions, I'm going to go with a Type A. No, your device will stop functioning very quickly, and it may not actually then do the job you want it to do when it becomes the critical time for safety.
Okay.
And so you select the right device for the right load, you follow manufacturer's instructions, but there are some requirements within 7671 that do point to a Type B device.
Okay, so if we looked at it on a hierarchy setup, so we'd say AC is at the bottom of the pecking order.
Yeah.
We've got a Type A, which is next up. We've got an F, and then we've got a B, which is the king of all. Now, if we look at it in that way, every time you increase that level, it's better than the one below it. It doesn't necessarily not do the function of the one below, but it increases with the hierarchy, doesn't it?
Yeah, and it's you would pick, obviously, the type of device for the nature of the connected load. And that's what it is every time. I mean, you're not going to stick a Type A in, or rather, you would stick a Type A in for normal, general types of loading that's within an installation. What you're not going to do is say, ooh, I'll go for a Type B because that's better, because it's unnecessary. You go for a Type B because it's the right one for the job. Yeah,
I think that's what I was getting to, is that if let's say the manufacturing instructions stated that it needed to be a Type F, and certain manufacturers didn't produce them, well, actually, we could increase the level and go to a Type B. That way, it's always going to be the one below. It's always
absolutely.
Going to be.
You could select a Type B instead of a Type F. Absolutely.
So, what is the differences between the two devices then? So, A, we've pretty much covered in most of our other videos. We're going to focus on F and B as well, then, Tim.
Perhaps just stick with B because it gives us an example of something that's at the top of the tree in terms of that arrangement. And so in indent 4 of 531.3.3, it deals with residual sinusoidal alternating currents of up to 1 kilohertz. So suddenly we've got something that's normally 50 hertz, type A AC, and then this thing goes, actually I can have a range of frequencies and this device will continue to function as it should, even when the frequency range is much wider. And again, like I say, this is more tied to frequency controlled motors and the like. And most motors nowadays where you want speed control and the rest of it is going to go for a type B device arrangement.
So even things like air source heat pumps as well, that's going to be included in there. PV.
Could be.
Battery storage, those types of...
EV, may well be in there. All of that would be where you would think about a type B device. The next bit in the list is for residual alternating currents superimposed on a smooth DC. Again, we're into slightly more complex areas, but it's all a function of the load. You've got residual pulsating direct current superimposed onto smooth direct current. You've got residual pulsating rectified direct current, which results from 2 or more phases. So again, this is a DC that always sits above the line, but it's going up and down. So there's a sense in which it's a case of how do I not get tricked by this tweaking DC that has all the appearance of sort of an odd AC that sits there. And then finally, for residual smooth direct currents, whether suddenly applied or slowly increased, independent of polarity. And so it sits under all of that, and a type B gives you a functioning device, even when all that stuff is happening.
Quite clearly a clever piece of equipment then. So when we look at going back to the threshold, I'm going to call it, what's the threshold of these devices? What level of DC can they cope with?
Generally, we start in around 10 milliamps. It's the threshold that it does, whereas a type A will be 6 milliamp.
So we've got a little bit of increase on there as well. So a lot of people will look at that, Tim, and go, that's the reason why I need to have a type B, because it can handle more DC on there as well. But we've also just to give you a complete list of things and the reasons why, because of that nature of that connected load, as to why we need to select a different type of RCD.
And it's also, Jake, perhaps something we need to just touch on, even though perhaps in other things we've looked at, is the fact that you stick a type B on the final circuit. You then have to be really careful about any RCD that backs that up.
Correct, yeah.
But that's a talk for another day, perhaps.
Yeah, and we won't go into all the coordination of devices. So there is going to be a Type B RCD within the range for 3-phase. If you are unsure about some of the parameters that it covers, please do get in contact with us. Don't forget, like, subscribe and share, and we'll see you on the next one.